ahead of myself. I'm saying bring down the 4. Yeah. Yeah, you know, every time I talk and I write, I gotta stop. So stop me when I make a mistake. I write slower than I think sometimes. So now, we got to here. Start like this. We saw in your calculator, -4 was here, -2 was here, and 6 was here. We pulled out your original coefficients. Don't forget the space holder. So now, let's work this through. Again, there's your remainder theorem. That's got to be a 0. Keep it there, because now you're at the x squared part. And yes, you can come and factor this. This is a nice trinomial to factor. If instead you want to still show me algebraically, take one of the next roots. So I know I did this one. So maybe let's take -2. Do it with this guy. Bring down the 1, divide down. You just have to show me synthetically how you get there. Because you can no longer show me by factoring if you have a cube. If at one part when you get to your quadratic and then you factor it, absolutely fine. You'll have to do that if you don't have a real 0 out there. So now you went down 3, 2 to 1. This is your factor that's left. And that's your other 0. So that's showing me algebraically how to get there. I like when I can keep synthetically dividing, especially if my coefficient in here is not going to be a 1. Because then I got to do the 8 times c. I got to go through a little bit more problems. But if you do it this way, you can find them all. Does everybody see this? You may not even remember this, but is it coming back to you? Okay. All right. Sometimes it's not possible to find them all, and sometimes it is. Now, perfect one in question here. They gave us the 1/2. We pulled out the coefficients, 3, 2, 1, 0. We synthetically divided all the way down. We came out with this factor. It's a quadratic. I can factor that. In fact, when I set it equal to 0, I can divide by a 2 because now I have an equation, not a factor, and I can factor that part. That's not so bad. That one's a doable one. If I came to this point and I factored out the 1/2, and I dropped everything down, I can stop right here and do another 0. I don't have to go to my quadratic. I know one of my other zeros, according to my table, was a 2. I couldn't even see the 1/2 in there because my table was incremented by 1, but they gave me the 1/2. That was kind of sweet. If you don't see it on your table, because it may be a fraction, do a zeros on your graph and see in fact if it's a rational number. If it's a fraction, you can absolutely divide by it. If it's irrational, no, you got to run your quadratic. So now let me take another one. I'm going to do the 2. So I bring this down. And again, my remainder theorem says that has to be a 0. I went from 3 to 2 to 1. This is my 2x minus 10. Set this equal to 0 and find your other factor. Is this making sense? Again, they gave us a factor. It's a cube. I don't know how to factor that guy. Everybody doesn't have an x. I can't pull an x out. So I'm a little bit stuck. So I'm going to have to divide synthetically. I pull out my coefficients, 3, 2, 1, 0. They're there. I divide by 2/3. This has got to work out at the end. This has got to be your 0 because they gave you this as a 0. So your remainder theorem says, I'm going to find that at my x-axis where y is 0. My remainder is 0. So this has to work out. And usually your fractions will work out because we normally don't have a quadratic that has a fraction in it. We never see that. We see it maybe when we do the a equals 1 and we have to change it ourselves, but we never see it in these cases. Now, this might be a good point to factor again at this point. Now the problem is, I'm not going to see these factors on my table. Can you find me one of these factors? If you had to, let's have you do this. Ignore this line right here. I can't get this out of here. But I'm going to divide now by 1/4. 1/4 is my 0. Okay? So pull down the 48. 48 times 1/4 is what? 12. This shouldn't be bad. I'm going to have to come out with a 0 here. I subtract this, I get negative 36. Negative 36 times 1/4 is what? Negative 9. Oh yeah, I got it. So now I went 3, 2, 1. 48x minus 36 is my other factor. I set that equal to 0. I get 48x is equal to 36, and I divide by 48. And I reduce it down, so this is down to 3/4. So I found, algebraically, all my zeros. I could absolutely have factored this. That worked for me. I found them here. But if I didn't want to be bothered factoring, and I always say, if you can keep synthetically dividing, you all seem to have a good grasp on synthetic division, keep dividing. The nice part about this, too, is that with the remainder theorem, if you don't catch that 0 when it's a factor, you did something wrong. And if it's a fraction, you're not going to see it on your table, but you can find it on your zeros. Does it make sense? Yeah? It was good to get my calculator back up here. I graphed this guy, and I noticed it's a little bit weird. We thought that we would find how many zeros? What's your highest? 4. Yet when I graph this, I'm only going to see it cross the x-axis twice. I hate this thing. Okay, let's graph this. I just care about my x-axis anyway, so let me see this. I happen to notice that this is only crossing the x-axis twice. So I've got 2 real roots and 2 imaginary roots. If I gave you a parabola that stayed above the x-axis, imaginary roots, it doesn't cross the x-axis. So I noticed in my calculator that I have 2 of these guys. And that works out well for me. If I'm at z to the 4th, I find one, z to the 3rd. I find another one, z squared. Can I take a z squared and factor that? Isn't that my quadratic? So I pull out my coefficients. I divide by either one first. It doesn't matter. Keep what you have left over. Divide by the next one. So I went 4, 3, 2. I'm here. This is a factor. When you set this equal to 0, and you take the square root, we've been saying that's not a real root, right? To take out the -1, this is your I, the square root of -1. So x is equal to plus or minus I radical 2. You have two real roots, you have two imaginary roots. If we're only looking for the real roots, then you just give me the real zeros. And you can stop there, say, whoops, those two roots, imaginary. I can't find those two roots. Okay. Sometimes they ask you for all real roots, real zeros. Sometimes we say all zeros. We don't do a lot with the imaginary number in here other than this. Just take out the square root of -1 so that we can continue to work with it. Really, that's all you use with your quadratic formula. You need the imaginary when you do your quadratic to describe your roots. Because we get stuck if we can't describe them. Okay with this? Okay. Okay. All right, this one was a big one. This one we noticed had 4 roots. And when we graphed it, we only saw it hit the axis 3 times. Because one of them bounced off the axis. And it's a good idea to graph these guys. You had to because you needed to find at least one root. And if this is a 4th, it only brings you down to a 3rd, you got to find another root. You got to get to the square. So look for 2 zeros. I look in my table to see when the y is 0. That will tell me that I have a 0. Okay. All we care about is what's happening at the x-axis. And again, if you can't see this, I expected 4. I could see like this one clearly here, and something's going on in there. So again, just change your window. Change your window. You got to see that one over there. So maybe go from -10 to +10. Just make your y-axis go from -1 to +1. You don't need to go far. You just need to see what's happening at your x-axis. And I could see something happening there. I could see 1, 2, and I could see this guy bounce off. There's my 4, 3, 4. I have a double root. When you look at your table, you're going to find 2 of them. You're going to find the 1 and the -6. There's your 1. There's your -6 is 0. That's all you care about. Once you get it down to 2, you can find the other 2. Doesn't matter which one you divide through first. I divided through the 1, then I divided through the -6. When I get down to here, I'm going to have to factor this guy. If you can see the 1/2 and do a second calc zeros on that, you can pull the 1/2 out of there. If you can't, and you should be able to actually, we can probably pull the 1/2 out of here. A little harder, but we can pull the 1/2 out. Since we don't really care about that one, let's isolate your window over here. Let's go from 0 to, I don't know where it's going, so I'll say 5. This is the one I can't see. I don't know what's going here. Here's my 1, 2, 3, I went to 5. So we've got a -6, we have a 1, and we got to find one of these guys. So if I isolate this one, second calc, find my 0. Isolate this one. I want to find out where this guy is. He's coming back down. You can always tell down here where your x's are. Okay, so I'm to the left of it, somewhere. Oh, wait, to the left. Mine's still traveling here. I don't know what happened to mine. It got caught in a loop somewhere. Alright, so I'm left bound somewhere. Then come to you past your right bound. And guess.
You have to do one first, like first of the division.
No, you can do either one first. Either one. It didn't work the other way?
Yeah, it's kind of weird. It doesn't fall.
Okay, so let's do the other one. You did the negative 6
Yeah, I
first?
did negative 6 first.
Okay, did you have all of these coefficients?
Mm-hmm.
We also found the 1/2 at the 0, so we can use that as well. This is a good one, we can walk all the way through it. So you did the negative 6. Good. Okay, so then you did the 1.
Yeah.
So keep this going, don't change anything. Good. Now, we also found a 1/2 in there. I'm just going to keep going with the 1/2. We found a 1/2 in there. The one we just isolated. Bring down the 2. This will give me 1. I bring this down. This will give me negative 1. This gives me 0. 2x minus 2 equals 0. This is my factor. Set it equal to 0. Oh, I noticed I got another 1. Because on my graph, it bounced off at the 1. That was my double root. You only have to write your double root once, but we do have to find it. Synthetically dividing, this is probably a very nice way to go. Get used to the calculator, because once you become more comfortable with that calculator, you'll feel better about all this. I realized the calculator's a little, I loaded you up with these. 4, don't forget you got a space holder for the 3. All right, I need to know 4 roots. When I do this, I see on my table clearly a negative 3 and a 4. I don't see these guys in my table because my table set was set at 1. If you want to change your table set to 1/2, you can change your table set to 1/2. It doesn't mean that your fraction will always be 1/2, but if you want to try that first, or zoom in on your screen a little bit by changing your window and find one more root. So if I continue with this guy, I take this out of here, I isolated another root. I'll go for the 1/2 and find the 1/2, and I can divide again. 4, this gives me 2. 6, this gives me 3. So 4x minus 6 is my root. Set it equal to 0. And x is equal to 6/4 or 3/2. So you never, if it's working out nicely, you don't have to find. You don't have to do your quadratic. Keep dividing it through. Or are you guys not used to getting up this early in the morning? Everybody's snoozing in here.
I'm not understanding how to get zeros. It's not working.
Which zeros can't you find?
The ones that, like, the halves.
Okay, so let's do this together again. Because that's important. If you can capture that, then it makes a whole lot more sense. So let me take a minute to get this in here again. Keep an eye that they're going in. Now, this graph is going to look a little strange, right? Let me just do a zoom 6 and start again on it. This graph is going to look a little strange. I have 4 roots, 3 terms, 2 inflection points. So I know it's turning around, I know it's coming back. I don't care about anything else but what's happening right here at my x-axis. Can I almost see the 4? Can you see this one? This one? If I look in my table, it tells me negative 3 and 4, right? Can you find that in your table? Can you see that in your table? Can I get rid of this one then and this one and just focus my screen on this? I see the 2 at the end, right? But somehow in that middle, that looks like a railroad track to me. So what I want to do is, I just got to clear this ink off. I don't know how to do it. Okay, what I want to do is just focus in that little section. So knock my x's down from -5 to 5. I know it's out there. And knock my y's down because I don't care where it turns. I'm going to just go from -2 to 2. -1 to 1. I only really want to see what's happening there. Now that goes other guys. That's cool. Oh, I can now see. Yeah, there's something right here. Do you see this guy right here?
Mm-hmm.
Why don't I shoot for that one? So get me a zeros. Now, if you're having trouble going left bound and right bound, this one makes sense to do it like this. Watch. We did these by tick marks. 1, 2, 3, 4, 5. My left bound says, look from, I know this is at -3, right? So there's my -2. Look from -2 and look to the 0. Don't do your left bound and right bound with your bug thing. Do it this way. And there's my point. If you want to flip it to a fraction, it'll probably be, I think it's easier to divide out by a fraction because they're all going to work out nicely. But if you want to leave it as a decimal, you can do that too. So you found another one, and now you can keep dividing through. Maybe, in fact, I wanted to find this guy. This might have been a little better for me to find. Can everybody use your left bound and your right bound without the bug? Can you use it with a number instead? That helps you pinpoint it a little bit more. Also, when you do this, watch what happens here. If I want to change this, look where my number is. This tells me where I am on my x value. I just passed by it. So if I want to kind of get in front of it, I come down here. Look where this went, to -2, past the -2. So I say, okay, I'll be past the -2. Now I just want to get closer to the -1. I'm close to the -1. Can you judge by that as well? Looking for where those x values are when you do your zeros? That's another good way to do it. Okay, so once you find one, the last one you can get. And I think, well, 2 more. This had 3 roots, so all I have to find is 1. I have to find 1 root. I find it in my calculator. I can't find the others because even when I do my zeros, it gives me an irrational number. And I can't round those off. I need my exact zeros. So I take the 1 root that I have, I get down to my quadratic. At this point, you could either complete the square or do the quadratic formula. It's not factorable. If you want to complete the square, do complete the square. This works out the same. So x minus 2 squared 4, 4. Oops, plus 1. Plus 1. So this gives you -3. And you can do yours from here. Add 3, take the square root, whatever it is you have to do. And then find it from there. You can do your, oh, I did complete the square. You could do your quadratic formula also. Those are the only things that's going to get you there. Because we can't find those exact roots in there. You can check those. If it looks so weird, go to your graph and do a second calc value. Put in an x value, put in one of your zeros. And when you do this, the y has to come back and say 0. That's a good way to check that you did have that root. And because they're conjugate pairs, you only need to check 1. The other one's going to work. And the last one, You had 5 roots to this. In your calculator, you have to find at least 3, because you have to get down to 2, to a quadratic. So there were 3 roots to be found. So if we get all the way down here, we keep dividing, get all the way down here, your last, God bless you, your last factor is this. When you set this equal to 0, this is fine, this is not imaginary, but it is irrational. So you have to give me the plus or minus radical 2. And again, put it in your calc, check all those roots. Do a calc on radical 2 and see if your y comes out to be 0. That was a long one. Can everybody do these?